Hello there. Today we're going to be looking at estimation procedures using SPSS. Now, the object of this branch of inferential statistics, which is estimation procedures, estimates population values or parameters from statistics computed from samples. Although this technique presented new to you, you are certainly familiar with their most common applications, such as in public opinion polls and election projections. So, for example, we can see this when politicians say 95% of Canadians, for example, believe in a certain ideology or policy, give or take a 5% margin of error. That would mean that at the lowest end, at least 90% of Canadians believe in it, or on the upper end, the majority, all Canadians believe in a certain ideology. Like I said, with say 5% margin of error, that is within 5% of the mean, which would be 95%. So from here, you're going to want us to click on the box that says IBM SPSS Statistics 20 and click OK. Once you click OK, another box should appear that says Open Data. From there, go to Documents, Courses, and then once you enter into the courses, you go all the way over to PoliSci 3N06, which is right here. So click on that, just making sure everybody's catching up. And then from there, you're going to want to click 2006 census shorten.save right by the cursor. So shorten.save. I know they have a whole bunch of them, but 2006 census shorten.save is the one we used, and it's probably the better one. Once the data appears on your screen, from here what you're going to want to do before we start this exercise is organize the variables so that way it can be presented much more clear. So what you're going to do is go to Edit, scroll all the way down to Options. In Options, what you're going to want to click under Variable List is Display Names and organize it alphabetically. Click Apply, click OK on the box that comes up, and click OK again. And now from here we can begin our exercise. The Explorer procedure is what we're going to be using, and we're going to be using the Explorer command for constructing confidence intervals for sample means. The Explorer procedure can be used to construct confidence intervals for the sample mean. The Explorer command produces many of the same summary statistics and graphical displays produced by frequencies and descriptive procedures, but offers additional features. Here we will use Explorer to computate the confidence interval for the mean of totonic, or what will be total income. So from the main menu, you're going to want to go under Analyze, and then Statistics, which is the second right after Reports, the second option. Once you go to Descriptive Statistics, click on the Explore command. Then the Explore dialog box should open. Use the cursor on Define Totonic or Total Income in the list on the left, and then click the right arrow button to transfer the variable into the Dependent List box. So like I said, go and find Totonic, which represents total income. Then click the right arrow and put it into the dependent list. SPSS by default uses 95% confidence level, which in fact is what we want to use for this demonstration. However, if you want to request another level, you can click on the Statistics button at the top of the Explore dialog box, which is actually just right of the dependent list box. So you want to scroll over and click Statistics. From here, when this dialog box opens, the Statistics dialog box, type the desired level that you want for your confidence interval, right where it says confidence interval for the mean. As you can see, it should already be set to 95%. But if you wish, you could change that variable to whatever you want. So for example, you can just take out the 95% if you wanted to, and you can put in 99% or 90%. So as I'm about to do here, 90%, 99%. But like I said, for this one, we're going to want to use 95%. And once you have the desired confidence interval for the mean, click Continue. And then once you have, make sure you have the correct variable in the dependent variable list, scroll all the way down to OK. And then once you click OK, the descriptive output table below should be produced. And as you can see right here, the descriptives table is produced. Now, the descriptives output table contains a variety of statistics used to measure central tendency and dispersion. Some of these statistics are not covered in this textbook, and if you wish to explore them, you can go on the SPSS online help facility. In this section, however, we focus on parts of the table related to confidence intervals for the sample mean. The values for the lower bound, which you can see right here, lower bound, and upper bound of the confidence interval mean. The lower limit of the interval estimate is 31,285.99, and the upper limit is 36,248.13. We estimate from this descriptive chart that Canadians on average have a total income of $31,285.99 and $36,248.13 because alpha was set at 0.05 as the level, the estimate being a 5% chance of being wrong, so i.e. of not containing the population mean for total income. This hereby concludes the first part of our SPSS demonstration for estimation procedures. Now we are going to move on to producing an error bar graph for the SPSS demonstration 6.2. Here we'll produce an error bar graph for the confidence interval for the mean of total income. So what you're going to want to do is you're going to go to graphs, which is right at the top of the main menu. Then you're going to want to scroll all the way over to graphs, like I said, right where the cursor is. Then you're going to want to click Legacy Dialogues, and then Error Bar Graph, or Error Bar. The Error Bars dialog appears with two choices for the type of graph we want. The simple option is already highlighted, and this is the one we want. At the bottom of the Error Bars dialogs, click the Summaries of Separate Variables radio button within the Data in Chart R box, and then click Define. Once you click Define, the Define Simple Error Bar dialog box with the variable names listed on the left will appear. Use the cursor to find Totonic in the list on the left, and click the right arrow button to transfer the variable to the Error Bars box. In the Bars Represent box, you have the option to select the error bar represents the confidence interval of the mean, the standard error of mean, or the standard deviation. For what we want to choose in this one is let's choose confidence interval for mean. So right where it says bar represents, scroll down, and then make sure it is clicked confidence interval for mean, the option that should already be selected. You also have to enter the desired confidence level into the level box. We'll use 95%, which it already should show, which is the default setting as I stated in the first demonstration SPSS uses. From here, scroll all the way down and then click OK, and the following error bar graph in your textbooks should appear. As you can see, this bar graph provides a better illustration of the exact information given in the descriptives output demonstration 6.1 that we saw earlier. What we can see is that the mean income of the sample respondents is about 34,000, marked by the small circle on the bar at the center of the bar, and we estimate at the 95% level of confidence indicated by the length of the bar that the mean income of all Canadians is somewhere between approximately 31,300, the small horizontal line at the bottom of the bar, and 36,200, the small horizontal line at the top of the bar. As you can see here, this allows us to be able to see with a 95% confidence level the range in which the total income of all Canadians is computed. And now we are now able to move on to the third demonstration for SPSS estimation procedures, in which we will generate statistical information for use in constructing confidence intervals for sample proportions. However, unlike the Explore procedure for constructing confidence intervals for the sample mean, SPSS does not provide a program specifically for constructing intervals for the sample proportion. However, we can use SPSS to calculate the sample statistics, namely proportions, on which the interval estimates are based. Once you know these sample statistics, the confidence interval for sample proportion is easily computed. To illustrate this process, we'll construct a confidence interval for MARST, which represents legal marital status. While we can estimate the population parameter for any of all the categories of this variable, let's estimate the proportion of the population that is married. First, you're going to want to calculate the sample proportion using frequencies command. Therefore, you go to the main menu, which is at the top, and then click Analyze. Then once you click Analyze, go to Descriptive Statistics, and then click Frequencies. When the Frequencies command box opens up, you're then going to want to scroll down and find MARST in the left-hand box. So you're going to want to do is scroll down, find MARST, click the arrow, and then it goes into your Variables box. Once you do this, click OK. I'm just going to give you a little bit of time to catch up. So click OK. And then what you should get is this box right here that says Legal Marital Status appearing. And from this box, we can then calculate the proportion of people who are married within the Canadian population. As previously stated, SPSS does not provide a program specifically for construction rules for the sample proportion. However, in order for us to be able to calculate the proportion or estimate the proportion of the population that is married, we'll have to enter in the variables manually or longhand into the confidence interval formula. Now, the confidence interval formula, as seen on the screen, is CI is equal to PS plus or minus Z with the square root of PU 1 minus PU over N. Now, for those who are not exactly sure what the formula means, the values PS and N come directly from the sample, and the value Z is determined by the confidence level, as was the case with the sample means. This leaves the one unknown formula, or one known variable in the formula, which is PU, which is the very variable we are trying to estimate. The dilemma can be resolved easily by setting PU at 0.05, because as we stated earlier, with our confidence level being 95%, we are allowing a 5% margin for error. So when we switch that over to a proportion, we get 0.05, and that will be our variable for PU. So when we want to start entering in our variables for the confidence interval formula, we get then 0.045 for then taking the amount of legally married people, which is 671, and divide that from the total sample mean, which is 1,500. Once you do that, you can get a proportion of 0.45. Where the Z score comes from is from calculating where exactly 0.05 falls between the mean, or finding the correct Z score, which turns out to be plus or minus 1.96. Therefore, you then enter in your PU data, and you get, in the brackets, you get 0.05, because it's then 1 minus 0.05, and then you enter it in. In the next line, you get CI is equal to 0.45 plus or minus 1.96, or 0.013. After that, you then multiply 1.96 by 0.013, and you get a confidence interval of at least 0.45 plus or minus 0.03. What this tells you is that using the 95% confidence level, we would have, changing back to percentages, we can estimate that between 42% and 48% of Canadians are married, based on taking 45% and adding or subtracting 3%. This ends the demonstration of estimation procedures in Chapter 6 for SPSS. So, any questions? Well, I guess that's it. Good night.